Hey guys, my name's Chris. This is Fully Defined, and in this video, I'm celebrating the fantastic Spring Open 2025 tournament we've just watched over on Too Tall Toby's channel.
We see Ate going for the mass, and we're going to find out if he got it correct. And we're watching the chat. Ate coming in with an answer, 544.3 grams. Ricardo Jean coming in with an answer, 544.3 grams. Guys, 544.3 grams is correct, and Ate is going to win that battle and win that point. And wow, 1 second difference.
With the battle between Ricardo Jean and Ate, both using SolidWorks across 4 models. And it was a thriller. It really went right down to the wire, and I was very impressed with both guys and their mastery of the different SolidWorks skills, given that the models they had to do were complicated with patterning, shells, sheet metal, multi-bodies, and a lot of speed required with some very tricky drawings. In this video, what I'll be showing you is my approach to these models and how we could achieve the results that the guys did. I don't want to take anything away from what those guys did live. From performing live in these battles, I know how it gets the heart racing. It gets the palms a little bit sweaty. It means your clicks, your moves with the mouse can be a little bit off. So what those guys did and achieved was fantastic. Doing things in a very relaxed setting without a timer pushing against you or a live opponent is very different. I've had the time to review some of these models here, reconfigure my initial approach to some of them. I definitely had some challenge originally with the sheet metal model and the very first model as well, the fan shroud. And I'll take you through those with a bit of commentary to go. So let's jump into it. All right, you can see the 4 models here that we've got in order: the fan shroud, the top left, bottom left, the bath caddy, top right, the sheet metal triangle, and bottom right, the bad idea. We got 4 models. It was very tight on the sheet metal, and both guys struggled with the multi-body one. I can see why. I definitely would have submitted one right answer at least in that one. But let's jump into them now. I'll take you through the process of how to build them and how to read the drawings as we go. Now, first up, for anyone that hasn't done these before, these are complicated models. This one in particular, a tier 5 model, although I would almost suggest that this should have been tier 6 with the amount of complexity in it, the amount of pink notes and dimensions required. I think it was a tier 6 challenge and really red hot for the guys to get first up. So you can see in the drawing here now, I'm going to have this off screen while I'm working, but I'll bring it across on the edit so you guys can see what I'm talking about as we go. But just to start, when we look at this model, the first time I approached this, I actually did it with a quadrant. So I thought I'd be smart and attempt this section by doing just one corner. I'd do that sketch, I'd do the hole, and then I'd do one of the round parts. I'd do my cut, pattern it, and then I'd do everything else, and it would be, a very quick way of doing things without dealing with the doing 4 of the holes or 4 of the cuts. It was a bad idea. It was a bad idea just because when you want to shell something like this, you need to shell it once it's already been patterned. And there's another tricky element, and this is the base. The very easy part that you can see in this model, which is this in this sketch here, the rectangle, the 55 by 55 with the radius. That actually, if you do that first, it makes it a lot harder to get the final model. Okay, you need to do a little bit more mucking around. And the reason for that is this section view that you can see down here. In the section view, the shell goes, let me just get a marker out. The shell that goes across this line here, you can see this bottom wall actually dips below it, right? So you have to have, but when you shell, it's this section here, this wall that's coming up is actually matching the walls of the conical shape that you've extruded. So that is the tricky thing. And I don't think during the modeling, either of those guys picked that up to start. I wouldn't either, but it's only something in hindsight that I saw that really simplified the approach. What the guys did, yeah, fantastic. I'm not going to talk too much about that, but let's focus on how we can replicate this one. So the trick, or the most efficient way to start this, is actually with the circle. So you want to start with these dimensions here, the 44 and the 30, because those are the ones that actually drive your model. Now you could even do a revolve for this. but we'll do it another way. Now, I'm going to hide that model and we're going to start a fresh one. I'm going to start on the top plane. And what we're going to do here is a circle 44, which is that dimension on that section view. And we're going to do an extrude. But here's the trick. We're going to go offset and we're going to use the height that we can see, which is 33. And then we're going to make sure this goes back up to surface being the top surface. And we're going to draft it out at a 4-degree angle. We can see 4 degrees on that section view for one of the sides. That is our first body. Our next body is going to be a circle on the top, 30. And then we're doing an extruded cut offset from surface. And you can see in the section view BB that it is 3 millimeters from the bottom. So we're going offset from surface 3, and we're going to add the draft angle here of 8 degrees. All right. Now we can here put the radius in the bottom, which is 1.5 millimeter, but the other radiuses we have to wait. It's at this point, with those 3 features done, we can do the very tricky shape that's going through the middle. All right, so that tricky shape through the middle, we can see all the dimensions in those bottom 2 views. We start a sketch on the front plane. We'd want to do a construction line up the middle for reference, and then we're going to do 1 line down. Make sure not to make it vertical, so we want to put a little bit off center. And then we want to do an arc at the bottom, followed by another arc, a straight line that's tangent, and then a line across the top. And then we're going to add dimensions. So that's the sketch that we need. The dimensions are all in those views as well. So that bottom of the arc is 25 millimeters from the top. And then we can just follow dimensions. We've got an R1, we've got an R42. I put this in, even though it's in brackets in the Toby Pink notes, it's still usable. I'm going to make sure that across the top, that's in the middle, and that this is 10 millimeters. And then each of these sides has 4-degree angle. And then you can see we've got a fully defined sketch. That makes that section like very easy. The hardest thing here is understanding exactly how that geometry is made. Once you've worked out that that cut is done once and then patterned, it becomes very simple. Because now what we need to do is a through all cut and then a 2 millimeter radius. You can see the blue radius is marked with an R2. If we select this face, that's going to do both edges for us at the same time. We can then select those 2 features and do a circular patterning, and there you go. We've got the main shape already. Now the shell was going to come into that now. So the shell, we can see there's a 1.5 millimeter wall thickness. So we've got 1.5 millimeter in here. We need to select all of these top faces and the bottom face, and we press OK. And it's at this point that we can then add that main rectangular shape that we can see from the very bottom, that we can see from that very top view. So we'll put that in 55 by 55, grab the radius tool. It's a radius of 6 in each. And we're going to extrude this up. But what we can do is convert that edge. So just on the inside, which means when we extrude this base up, line 3 millimeters, it's not going to impact the shell. Right? So it's going to merge the body, but that shell remains like untouched. And that's how we get this section view, like you can see in section BB. And then you're going to grab the fillet on the outside. And the very last step is the holes. Now, any hole like this, you can use the hole wizard tool in SolidWorks. The trick, select the face, select hole wizard, make sure you're in metric, and then press custom sizing, and then put in the numbers you need. In this case, we can see it's 3.1, 7 and 1. So 3.1, 7 and 1. I just need to pick the positions. So it's 4 points. And this is why originally I thought I could do 1 and then pattern it, but no, that would have been incorrect. That's all the detail done. If we check now our measurements, we get a weight. The material's already applied to this, ABS, the weight of 15.12, and that is correct. That is your first model. All right. So yeah, as I said, the really tricky point I fell into first time around, trying to get too complicated patterning from the start, also doing the very simple shape first. I'd love to hear from Toby if when he was doing his auditing, what kind of process he went through to get this, because yeah, doing that rectangular shape afterwards is definitely a good trick here. And then yeah, just understanding that cutting process and the circular patterns. If you're able to do that, that's going to save you a lot of time. All right, let's jump on to the next one, which is in these models, this was the multi-body model. And boy, this was tricky as well. This is labeled as tier 6. So the guys basically had 2 tier 6 models to kick off. And the guys didn't get the answer right on this one. So yeah, they're very, very challenging. Through my previous experience and my work, my typical workflow, I feel very confident with multi-body. It's how I work probably, 90% of the time. And even from the last tournament, there's a few skills I picked up. In this case, the indent feature, one I haven't used much before, but is very handy in this. Really speeds up the process. So yeah, I had a similar challenge in my last tournament entry where we had a multi-body with some tube detail. As this, I used a very similar process for this model. So let me take you through it. And yeah, we'll try and to get that answer. So you can see the answer there, 9255. That'll be within tolerance. Let's go. Let's get into that. I'll just label this as attempt 1 and hide those bodies. All right. Now, whenever you have the multi-body files, it actually doesn't matter which template you start with, so long as you're in the right units. You don't need to be in plain carbon steel or ABS because you need to apply the material to each of the bodies anyway. You might save a few seconds by starting in a plain carbon steel and just adding ABS to the other 2 bodies or 3 bodies which need it. But yeah, if you want to be safe in something like this, you would add materials to everything anyway. All right, so in this one, my approach, I know that the simpler form, the easier form is the tray, or in this case called the shells. It does have this tricky element with the little cutouts in the side, and you can see from this detail view that cutout has a gap to the pipe. That's something that I missed in my first attempt, and I had the answer wrong, but I could see that, identify that pretty quickly and make an adjustment to one of my features to rectify that. But seeing that detail, that the tube actually indents or moves the face away for the shelf, meant that I would do the tubes first, and then that would make it easier to do everything else afterwards. Now, of course, it's symmetrical body, so we only have to do one side and then mirror it. And the same things with the shelves. There's 3 of those, which are all duplicates. So you do one of those, and then you're able to do a linear pattern. So that's the approach we'll take. We're going to use a bunch of information from these sort of front, top, and side views to get the tube set up. You can also see in this detail view the tube OD 25, ID 20, meaning that the thickness is 2.5. If we can do a sweep and we can do a thin feature sweep, we can actually do all that in one detail once we get the path right. So that's what we're going to be aiming for here. So it's all about setting up sketches. Now, there is, a more efficient way than doing it. What I've done in my first attempt would be to try and do the whole thing with a 3D sketch. The only difficulty you can have with a 3D sketch is it's a bit harder to do offsets for measuring things and checking you got things in the right place. So from that point of view, I like to keep it simple, more straightforward. So what we will do is actually draw a rectangle to start. And this rectangle is going to set our size. So we've got a real guide for how big the thing needs to be. Now there's that tricky gap in the middle, 25 millimeter gap between the tubes. You need to include that in your calculations. That was another place where I got stuck on the first time around. I'm just going to set it like this. So this box just sets a very quick guide for like the end points of the tube. It's going to make it a lot easier. Now my aim here is to actually get I'm going to use solid bodies and a couple of fillets to create a 3-dimensional curve that I can then use as a compound curve and then convert into a sweep. So it might look a little bit funny what I'm doing to begin with, but there is some reasoning to it. It's all going to start with an extrude like this, or a rectangle, should I say. And for this rectangle, I'm trying to find the center line of where that tube is. Now I know that there's a 25 millimeter gap here to the edge of the tube, which means from here to here is actually going to be 12.5. And then from here to here is going to be 12.5. Right? This line, you can imagine, is the center line of my tube. Similar thing at the bottom, 12.5. And then our radius, we can see it's got an inside bend of 50. Oh, we can see that in the bottom left corner. Now that would mean the middle bend will be 50 plus 25 divided by 2, 62.5. We could put that in here, 62.5. And if we were unsure for any reason, we could do an offset, 12.5. We can select those 3. We can see that this one here, being the inside of the tube, we can see it's got about 50 mil radius. So we are happy with that. Now, I'm going to extrude this solid, and I'm going to extrude this 430 minus 25. Because remember, I'm trying to get the center of my tubes. So I've got this curve on one side. I need to join it on the other two sides. Now we can see again, there is a 50 for the inside bend, but we are wanting the central section. So in the fillet that I'm going to do here, I selected the wrong edges, but I'm going to select these two edges. And now can you get an idea of what I'm trying to do? Create this solid body with a couple of fillets. I now have an edge that I can use, but I can do the whole thing, the whole tube very easily now without even creating a compound curve. So I'm doing a sweep. I've made the diameter 50. I've given it a thin feature, which is the wall section of 2.5. I'm going to unmerge it. Okay, I'm going to hide this body, and then that should be my tube. Let's do some checks. So outer diameter is wrong. Sorry, that should be 25. That looks better. Okay, so outer diameter 25, and then if we have a look from our top view, we can see here that this should have a radius of 50. Yep, and then the same on this front view. Again, we should have a radius of 50 for this curve, which we do. And then based on our very first sketch, we can see as well, do have a problem here. It's too big. I need to take off 12.5 off that dimension. That is an error that I need to fix up. Let me just undo this. So where I've drawn this line, that's the line. I just need to bring that in ever so slightly. That should be 12.5 on the inside. So now you can see our sketch that's on the outside of this has the right dimensions. All right, so that is our tube. That tube that's done. There's a couple of holes that we need to put through it, but otherwise that's up to date. So what we can do is select a material for that tube. Go material, plain carbon steel. That's applied to that body. So now when I mirror that body, it's already got the detail on it. Okay, looking good. Now for the shelves. Shelves, a little bit easier, yeah? So we're going to go on the top plane, and we're going to go follow the dimensions that have been given. So for the shelf, we can see it is 390 by 275. And there is a radius on those shelf of 50. So you can see the pink notes are 50 for the outside corners. Now the position of the shelf, you can see it is offset 100 millimeters from the bottom, and the height of a shelf is 90. We're going to go blind, offset 100, and very important, we uncheck merge result. Now I'm just going to isolate that shelf so we can finish the detail of this before we need to do some work between the two bodies. So we've got the outside radius, let's get the bottom radius, which is an R20. We then need to do the indentations. So this is the new skill that I picked up from the last tournament. This is indent. Our target body is the shelf. Our tool body, these two parts here. Okay, so the tubes, we're going to do a cut. So it's going to cut the material, and we're going to offset that cut by 1 millimeter. This is what gives you that 1 millimeter gap that you can see in that detail view on the very top. Now, when we do that indent, it leaves these little elements of material on the inside that we want to get rid of. So I'm going to make sure to delete those and also delete the first solid body that I don't want anymore. And now if I isolate this body, you can see those lovely cuts that we've got through on either side. They are perfect for us to keep going with. Now I'm going to put those fillets on. So they both have a 10 millimeter radius on those edges. And then there is a wall thickness of 6 millimeter. So we're going to shell the whole thing, 6 millimeter, exit isolate. That body is almost done. We just need to do the whole detail. Now, just before we do that, let's have a look from the top view. And you can see the clearance we're talking about. So that has a radius of 13.5, which we can see in that detail view as well. So that's looking really good. Let's do our holes. Now for our holes, we can see that there is a dimension of 20 millimeter from the top edge, and the hole size is 10. So I'm going to select here, the midpoint, make it vertical, and put that dimension of 20. I'm going to mirror this. And the other thing I'm going to do with this one is do a linear feature pattern. So while we don't need it for the holes in this shelf, we do need it in the holes for the tubes. And there's 3 copies of these, and each of them are 270 millimeters spaced. So now when we do our extruded cut, we're going through both. The holes for both the shells and the tubes is done all at one time. And then our only remaining step is a linear feature pattern. So our direction, we're going to go up. We're going to use this body. We're going to go 270 millimeters, and that should be all the body work that we need. Now, we just need to assign our materials. So we can see that these two are already plain carbon steel. These three are going to be ABS. And now, if we've done everything right, we'll get an answer of 9255 plus or minus 7 grams. I have 9253 plus or minus, which is within tolerance. Within tolerance. Let me just see if I have the same answer on my attempt number 1. Attempt number 1, I had 9254.517. So I have something very different between these two versions, but both within tolerance. That's interesting, isn't it? If we just have a look at the two, we'll see if we can spot any difference between them. Make them all transparent. They all look very, very similar. So look, we're in tolerance. I've got a very slight difference between the two, but I'm pretty happy with that method and pretty confident with our result there. So 2 down. This is taking a bit of time because these are complicated models, but let's go and complete the last 2 now to complete the set. So number 3, this was Artse's model, the sheet metal, and this was super close. Very tricky model. First time around for me. I don't spend a lot of time in sheet metal, so I was very rusty on this. And again, on this one in particular, your process for creating this is going to have a really big impact in how easy it's going to be for you. Right? I found, for instance, if you do that first shape, the triangular shape from the top view, and then do all the edge flanges, so the first 3 edge flanges all in the one go, that's going to stuff up the detail that you can see in this little detail view in the top left. So, an experienced user would see that or know that doing those edge flanges at once will actually create that kind of corner detail you don't want. You do those 2 edge flanges separately. So you do the 2 sides as one edge flange feature. You do the long edge in a second edge flange feature. You get a very neat result. Okay, and that makes things much, much smoother. So let's get into this. I'll hide the first one and let's start again. So this is going to be top plane, and what we've got to do is dimension the shape that it's given us, which is the 100 mil with an edge at the top, which we don't know, comes down and then across, and we put in our dimensions. So 100, 180, which is the start, the bends, the pink notes, very, very useful. And then the angle, 15. And then we're going to convert this into sheet metal, or start a sheet metal part, but make sure that it comes up. So reverse direction up. I can see 3 millimeter thickness, and I'll just delete everything else I did in the first one, just so I get the full sheet metal experience for you. So base flange feature. If I then edit that flange, I can see, well, that's got the thickness. The sheet metal feature has the radius of 3 millimeters. So both of those, good. So edge flanges, we're going to select the left side, the right side, put in a length of 24, uncheck offset, and then here you can see when we do this edge flange, we've got all the right settings there, press OK. See how it's got a nice sort of square edge across the top, and over here on the right, that's what we needed to do. If I did an edge flange that had these 3 in, you can see how it makes this different detail here. That is not what we want. So keep it to those 2 edge flanges first, and then do a separate edge flange for the long edge coming up to that point. And you can see it keeps a really neat result there. And then we can keep going very quickly with the rest of the model. There's a couple of slots to cut here. So we use the slot tool to sketch them. We want to use a construction line that is parallel across that outer edge. This is another reason why you can't do those slots in the very initial sketch, because you need that outside edge to get the geometry right. Without it, it's going to take you a bit of extra time, a bit of extra mucking around to get right. Also, you want this outside edge to dimension from, because you want to go to the middle to get your 60 and then your 80 mil dimensions. Now it's going to cut, we're going to cut through all, press OK. And now we've just got that neat little edge flange to do that wraps around. Now I saw Ricardo do this one. He was using some thin features. I'm not sure if Arce nailed this one as well, but again, pressure situations, it's difficult to know just off the top of your head the best solution. The way to do it is with an edge flange. You need to do them separately, one at a time. So I'm going to select this edge. I'm just going to drag it out. I've already got the height in the right position. It's angled here. I need to select this box, this face, and then you can see it's perfectly in line. I need to make it offset, and I'm offsetting it the thickness plus the gap, and the gap is 0.5. So 3.5, and then my distance is going up to vertex, which I can select here, press OK, and that is how you create that wrapped edge in the most efficient manner, as far as I know. Do the same on the other side. The offset carries over, and OK. The reason you can't do them both in one is because you can only make them parallel to one face at a time, maybe, or one angle at a time, because there's different angles. The one on the left is bending more than the one on the right. I'm pretty sure. Let's just see. I'm pretty sure if I grab this one, yeah, see, it's going to bend a lot more. Can I select the face for that one too? No, it's not going to work. It needs to be separate. Is that all the detail? I think so. And yep, that's the answer, 554.5. I think the answer in the chat on the day was 554.3. This is plus or minus 0.2, so that's within tolerance. Pretty sure this is acceptable here. So that's a nice quick one. Let's jump on to number 4. The very last model, I think I'd seen this somewhere else, maybe in a recent Monday Model Live, or maybe in the practice models. But Toby's picked it out for use as the backup for the tournament here. The easiest, I think the easiest out of the, the easiest out of the 4 models the guys got. So nice and quick. And this was really a speed challenge. Not too many complicated things in this. You just have to get the order of the parts right. Get the order of the parts right. Do some fillets before, some after, and then you'd be able to complete it without too much hassle. So the approach for this kind of model, even though it's symmetrical 4 ways, just trying to do one quadrant and then, mirroring it is probably more trouble than it's worth, again, because of the shell feature that's required there. So you could very easily do the top square section, extrude up. One thing not to do when you start is to fillet those corners, because when you draft it, those fillets are actually going to draft in as well and get smaller as they go up. So those fillets need to be added after the draft is added. But once you do that, you could do the top side first, the second cut down first, the cut through each side, add all the fillets, shell, and you're done. Let's give it a go. All right. So top plane, we grab our dimension tool, 137, 137, extrude up. We can see the full height is 54, and there is a draft angle of 10 degrees. So get that in. We can do our fillets here. So you can see the fillets in the green marks are 25 for all 4 sides. You want to use selection filter when you can. Then on the top, one of the reasons why you want to get those fillets in is because, actually I'll take that back. On the top, it's the similar thing. Even though you can offset it, you can see there's an offset thickness of 15 millimeters. Okay, and you'll get the radius there. When you cut down and you draft that, it's going to, again, draft the radius, and that's not a good result that you want. So you want to do a rectangle sketch. You're better off making these all equal and then just dimensioning one side for that offset, which is 15. Then you get cut extrude. Now the cut is going down to 22 offset from the bottom, and it has a draft of 10 degrees as well, coming on the inside. All right, so we do that draft. Then we're going to do those internal fillets, which are a 10. Try and use the selection filter to get those 4 dark ones. Then we need to do a cut. Now the cut is a straight slot. Sketch your slot. Hopefully you get it vertical first time. Dimension right. We've got 9 degrees radius, 12 depth. We're going to do extruded cut. Do it through all both. And you can radius here. Yes, you can. It's 7. If you can get all 4 edges with the right selection, it's pretty quick. Now, if you want to pattern it, you need an axis. So you'd want to do that pretty quick and then select those 3 and do a circular pattern. Just change it to 90 and to 2. But you might get issues with the fillet. Nope, that's okay. I think that's all the body we need. And then we're able to shell 4 millimeter wall. And there's our answer correct, 180.8. We've got that, and that is it. Very quick model to wrap up. Oh boy. So yeah, look, some awesome challenges from Toby and the guys, Ace and Ricardo Jean. Congratulations to those guys, both for making the final, which is definitely an achievement in itself, and Ricardo for taking it out, going into the Hall of Fame now. Really love watching. A bit bummed with the time zone stuff, but that's just how it is. Yeah, happy to stay involved this way. and hope you enjoyed seeing these walkthroughs for those very difficult models. So yeah, appreciate you tuning in. I'll see you in the next one, guys. Bye. Hey, thanks for watching the video all the way to the end. If you enjoyed it, please like and share. If you've got any suggestions for other content, leave it in the comments below. If you haven't already, please subscribe. And there's some other videos here. Check out. Thanks.